Okay, so we're going to look at trig ratios of acute angles. Now we're used to seeing our primary trig ratios. So what are those? Well, that's our SOHCAHTOA. Okay, so that's our right angle triangle. Say there's my angle there, right? So that makes this adjacent, this opposite, this hypotenuse. So the primary trig ratios are sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, right? Okay, so we're good with those. The reciprocal trig ratios, we're still dealing with the same triangle, only remember reciprocal means 1 over, right? So I still have my theta, I still have my adjacent, my opposite, and my hypotenuse. So now we've got some new ones that we have to worry about. So cosecant is 1 over sine, which means instead of opposite over hypotenuse, it's hypotenuse over opposite. Secant is 1 over cos. So instead of adjacent over hypotenuse, it is hypotenuse over adjacent. And the reciprocal of tan is my cotangent. So 1 over tan, which is, instead of opposite over adjacent, adjacent over opposite. Okay, so there is a reason and a purpose for these. You're getting introduced to them this year, and you will see the power of them as you continue in your schooling. Okay, so these guys had names. Let's maybe write out our names here. So CSC, that's our cosecant. Our SEC is our secant. And the last one, the COT, that's our cotangent. All right, so let's do this. We just want to state the primary trig ratios and the reciprocal trig ratios for this triangle. So that just means I want to write the fraction. I'm not solving for anything, okay? So if this is my angle of interest, we have to label based on that. So over here is my opposite, touching it is my adjacent, and the longest side, so the one that's across from my 90 degrees, is my hypotenuse. Okay? So to write out my trig ratios, we're writing out sine theta, which is opposite over hypotenuse. So that means sine theta is 3 over 5. We're writing out cos theta, which is adjacent over hypotenuse. So that's going to be 4 over 5. And we're writing out tan theta, which is opposite over adjacent. So 3 over 4. So those are my primary, okay, primary trig ratios, and that's all you got to do. You're just writing the fraction. That's it. Okay. Now our what's the other ones? Reciprocal trig ratios. That's our new ones. Okay. So the inverse of the sine is the cosecant. So that's going to be hypotenuse over opposite. Oops, cosecant theta is 5 over 3, right? So they're the inverse, they flip. Secant theta is going to be hypotenuse over adjacent. So that means it's going to become 5 over 4. Right? You're flipping. That's what reciprocal means. You just flip. And then cotangent is going to be adjacent over opposite. So cotangent is going to be 4 over 3. That's all you got to do when you write the ratios. Okay, let's solve for our angle. So if I gave you cos theta equals 10 over 7, well, how would you figure out that angle? Well, let's see. We know cosecant is the same thing as 1 over sine theta. And I have to go there because guess what? There's no secant button on here. Nope. So we got to figure that out. So I know cosecant is 1 over sine. And I'm being told that all of that equals 10 over 7. Well, in order to solve, you can cross multiply and note that sine theta is going to be equal to 7 times 1 over 10. Or you can just notice that they both flip. So that would tell me that sine theta over 1 is the same thing as 7 over 10. Flip both fractions. So either way works. Gives you the same answer. So let's solve. So remember theta, to get that alone, you have to find the inverse. And so you're going to be typing in 7 divided by 10, right? So second function sine, 7 divided by 10. Make sure it's all inside the brackets. You're going to do it all in one step. Equals 44.4 degrees. Okay, let's try another one. So let's say this time I have cotangent theta equals, I don't know, let's say 6.2. Sure. So cotangent, that's the reciprocal of tan, right? So that means 1 over tan theta is equal to 6.2, and I'm just going to put that over top of 1 to make my life easy. Flip both fractions, right? So that tells you that tan theta equals 1 over 6.2. Get your theta alone. So you have to do tan inverse, so your second function of 1 divided by 6.2. Type that in. So you get tan inverse 1 divided by 6.2, and it gives you 9.2 degrees. Good. All right, so let's do this example here. So given the right angle triangle, we want to determine all 3 reciprocal trig ratios, and we're going to solve for the angles. So let's see, I don't know, which angle do we want to choose? We haven't really done one with one up here, so let's choose that angle as our angle of interest. We need to solve for both angles, but let's start with one. Okay, so if that's the case, the side that's touching it is my adjacent. The side opposite is over here. So there's my opposite. There's my hypotenuse, but I don't have an answer for it yet, so I need to find that first, right? So Pythagoras is going to help me out here, right? I know 2 side lengths, so I can solve for the third. So c squared equals, let's see, 12 squared plus 19 squared. So c squared equals 505. Get the square root of both sides, right? Because that's how we get rid of it. And we only care about the positive one because these are lengths. So c is square root, is 22.47. So there's my hypotenuse. So let's see, determine the reciprocal trig ratio. So cosecant angle is my 1 over my sine. So sine is opposite over hypotenuse, so I want hypotenuse over opposite. So that would mean it's 22.47 over, who's opposite, 19. Secant, and my angle is 1 over cos. I always remember it as they're the opposite letters. I don't know. Cos is adjacent over hypotenuse, so that means I want hypotenuse over adjacent. So that is my 22.47 over, who's adjacent, 12. Good. And then cotangent, let's get that one in there. Cotangent angle is 1 over tan. Remember, tan is opposite over adjacent, so this one's adjacent over opposite. And that would give me 12 over 19. So there I have my 3 reciprocal trig ratios. So ratio just means fraction. And then now I want to solve for my angle. So let's solve for this one. So how do we do that? Well, we pick one of these. Pick one. I'm just going to pick the top one because why not? Ooh, maybe let's pick tangent because there's no decimals. Yeah, let's do that one. So I'm going to use, you can use any one. Cotangent theta is 12 over 19. Well, cotangent is just 1 over tan. 12 over 19. So my calculator knows tan. So I'm going to flip my fraction, right? And once I've flipped my fraction, I can then calculate. Can you see that okay? So angle is, bring tan to the other side. So it's tan inverse of 19 over 12, right? We need that second function tan. So make sure you type it in. I do it all in one step. Make sure you use your brackets. Tan inverse equals, so that angle would be equal to 57.7 degrees. Now the question wants all the angles. Well, we're smart people. We know that the angles all add up to, what, 180? So that means 180 minus 57.7 minus our 90 equals the missing angle, minus 32.3 degrees. So I don't know, I didn't give that a name. Let's call that theta.